Okay, when you're multiplying matrices, A and B can only be multiplied if and only if the number of columns in the first is equal to the number of rows in the second. And again, when we're thinking about columns and rows, columns always run up and down. So your columns, and then left to right would be your rows. So do keep that in mind as you're going through these, because it can get confusing. If matrix A, and we're going to use this down here at the bottom. So using the examples at the bottom, if matrix A has dimensions m by n, and matrix B has dimensions n times p or n by p, then the resulting dimensions of AB is going to be an m by p. Is that okay? Now, looking at this, keep in mind when you talk about your dimensions, you're talking about rows by columns. That's what you're talking about. All right, so on our examples here, they want us to tell whether or not we can multiply these matrices, and then if we can, we need to tell what the resulting dimensions would be. So for this first one here, if I'm looking at matrix A, well, let's go count the dimensions for matrix A. You've got 4 rows and how many columns? 1, 2, 3 columns. So that's matrix A. And then for matrix D, let's see what those dimensions would be. You've got 1, 2, 3 rows and how many columns? 1. So that's a 3 by 1. So in order for us to be able to multiply these, the number of columns in the first has to equal the number of rows in the second. In this case, they do. And so you can multiply these, and the dimensions of your answer would be a 4 by 1. Looking at number 2, again, same idea. Let's pick out our dimensions. The dimensions for matrix A was a 4 by 3. Go count up the dimensions of matrix C. Matrix C is a 2 by 4. And again, the number of columns in the first has to equal the number of rows in the second. Notice those two numbers do not equal each other, so here you would not get a product. You are not going to be able to multiply those two. Okay. Looking at number 3. So again, the dimensions of matrix B. We go over and count. Matrix B is a 1 by 5. Matrix E is 5 by 2. Awesome. So for here, again, number of columns in the first has to equal number of rows in the second. Notice they do. So this one, yes, you can find the product, and the dimensions of that product would be a 1 by 2. Okay, so number 4. Checking that one, your dimensions of B was a 1 by 5. And then your dimension for matrix D is a 3 by 1. And again, these numbers here are not matching. The number of columns did not match the number of rows, so that would be a no. Number 5, your dimensions, you have a 2 by 4. And you're multiplying that by 4 by 3, so definitely you can multiply those. and your dimensions of your answer would be a 2 by 3. Number 6, again, checking those dimensions, you have a 5 by 2. And then the other one was a 2 by 4. And so that's going to give you yes, and your dimensions would be a 5 by 4. It's a big matrix. All right, number 7 was a no. Hopefully we got no there. And then number 8 was yes, and your dimensions would be a 3 by 5. All right, so to multiply these, first thing you need to do is check your dimensions. So the first one that we have is a 2 by 2. The second matrix is also a 2 by 2. So I am able to multiply these, and I know the dimensions of my answer. I know that answer should look like a 2 by 2. So to multiply these, you have to be super careful. And what you're going to do is take this entire row and you multiply it to this entire column. And you match up number to number in your multiplication. In other words, you're going to say negative 4 times 6 plus negative 9 times negative 5. After you find that sum, that is your first element. And we'll go back and number crunch it here in a minute. Now you're going to skip over to the next column. So in your answer, skip over to the next column. And you're going to repeat the process. Negative 4 times negative 1 plus negative 9 times 4. And that would finish that element. Notice there's no more columns, so I'm going to close my bracket, and I'm going to drop down a row over in my problem. So now I'm going to go back and grab this row, and I'm going to repeat the process. So I'm going to take this row, multiply it to this column, and I'm going to have 3 times 6 plus negative 2 times negative 5. That's going to be your next element. And then the final element, you're going to multiply over here again. So you're going to get 3 times negative 1 plus negative 2 times 4. That's going to be your final element there. Now you're going to get your calculators and you're going to number crunch this, because what I have written is what I need to see from you. The rest of it can be done with your calculator. So I'm going to start my matrix below this one. And when we number crunch this, that's going to be negative 24 plus 45. So that's going to give you 21. Then you're going to have, and I'm still going to work in that same row, you have 4 and then negative 36, so that's going to give you negative 32, isn't it? And drop down a row. So you're going to have 18 plus 10, so that's going to give you 28. And then our final element, you're going to have negative 3 and negative 8, so that's going to give you negative 11. And do notice you get a 2 by 2, which is what we said should happen. Okay, try number 10. Again, check your dimensions. You've got a 2 by 2 times a 2 by 2, so you can multiply these and your answer is going to be a 2 by 2. So I'm going to start my matrix. And again, very similar process. You're just going to take your row, multiply it to your column. And when you do that, you're going to have negative 2 times 8 plus 0 times negative 2. And all of that's your first element. Then we go to our next column. We're going to get negative 2 times negative 3 plus 0 times negative 9. That again, that's going to be your next element, and you're going to close your brackets here because you don't have any more columns to multiply through. So go back. Now we're going to pick up that row and multiply through. So you're going to have 6 times 8 plus 4 times negative 2. And again, there's that element. And then multiplying over to the other side, you're going to have 6 times negative 3 plus 4 times negative 9. And now that you have all of that multiplied out, you are now going to condense all this down. So it looks like your first element is going to be negative 16. Your next element is going to be 6. The next one looks like you're going to have 48 minus 8, so 40. And then negative 54. And again, notice you did end up with a 2 by 2, which is what we said should happen. So number 11, we need to check our dimensions again. So the first one is a 2 by 3, isn't it? The second one is a 3 by 1. So we can multiply them. The dimensions of my answer should be 2 rows and 1 column, 2 by 1. Right, so let's go ahead and try to multiply these. And again, you're going to take that whole first row, and this time you've got more than 2 elements there, and that's okay. You just extend it to however many times this column here. And so when you multiply, you have negative 7 times negative 6 plus 2 times 4 plus negative 11 times negative 3. You don't have any more columns, so you know you're going to close your bracket. And now you come back down to the other row and pick up again. You're going to take this row and multiply to this column. So you're going to have 3 times negative 6 plus negative 5 times 4 plus negative 2 times negative 3. All right, so now we're going to put all this together for our final answer. So we're going to have 42 plus 8 plus 33. So that's going to give us, what did we get there? 83. And then our next one, we're going to get negative 18, negative 20, and positive 6. So that's going to give us negative 32. Again, we need to check our dimensions. Let's see. The first one is a 1 by 2. The second one is a 2 by 4. So those are going to match. Your dimensions of your answer should be a 1 by 4. Okay, now we're ready to go through. And let's see, that means I have 1 row and 4 columns, right? So this one's going to look a little different. I'm going to start my bracket, and then we're going to go through and do our multiplication. And again, you're taking that row to this column. So you're going to get 2 times 3, so you're going to have 6 plus 16. That's going to be that first element. Then you're going to go to the next one, and that's going to be 20 plus 56. That's your next element. And then you've got your next one, so that's going to be negative 8 minus 40. And then your final one, you're going to have negative 6 and positive 48. Okay, now let's put all of that together. And you're going to have 22, 76, negative 48, and positive 42. And again, notice you got a 1 by 4. Okay, Okay, so in number 13, if we continue on our pattern, then we are going to need to check our dimensions. We have a 2 by 2, and then our next one is a 2 by 3, and so those do match, so the dimensions of our answer should be a 2 by 3. And so now multiplying this out, again, you're going to take this row, multiply it to this column, and so you're going to have negative 27 plus 5, and that's going to be that first element. And then you're going to go over to your next one, multiply here, you're going to have 117 plus 35. And then again out here, you're going to have negative 45 minus 10. And we are finished with those columns, so we are going to close our brackets. We will drop down and go through our next set of problems. So when I multiply those out, I'm going to get 6 and then plus a negative 4. My next element, that was that one, then this one, we're going to have negative 26 minus 28. And then the final one, we're going to have 10 plus 8. Now we're ready to combine all these values, and we should end up with negative 22, 152, negative 55, and our next row we should have 2, negative 54, and 18. All right, number 14, if we check our dimensions, we will see that we can multiply these. So let's go ahead and jump to our answer. Looks like our answer is going to be a 3 by 3. And so when you multiply these out, this one seems a little tricky because you've only got one element and one element. So when you multiply those, you're going to get negative 14. Then you go to the next element, you're going to get 126. The next element, that's going to give you 70, and you're finished with that column. So we're going to close our bracket and pick back up with our next row to our next column. So that's going to be 2, and then we're going to get negative 18, and then negative 10. We're finished with that column, so we're going to drop down a row again, and we're going to get 6, negative 54, and negative 30. All right, moving on to number 15. Again, checking the dimensions, we are able to multiply this. So I'm going to go ahead and start our bracket. And again, we're going to take this entire row, multiply it to this entire column. And so we're going to get 0 plus 16 minus 6. And again, all of that's that first element. Multiply the last column here. We're going to have 14 minus 88 plus 5, and that is all of the columns. So we're going to close our bracket, drop down to our next line, and again take this whole entire row to the entire column, and multiplying there you should get 0, you're going to get 6, and you're going to get 24, and that again is going to be that whole element. And then the last one, multiplying this through, you're going to get 105, minus 33, and minus 20. And again, all of that is one element. So now we're ready to write our answer. We're going to combine all of these, and we'll get 10, negative 69, 30, and 52. Moving on to number 16, and again, you can multiply this, and this one's actually going to turn out to be just a 1 by 1. You're going to take this entire row, multiplied to this entire column, and you're going to get negative 112 plus 5. And so now we're going to combine those, and you're going to get negative 107. Okay, in number 17, we are going to go through, and we need to look at the product of matrix A and B, and then the product of B and C, and see what our values are. So if I find the product of A and B, and again I'm doing the same multiplication I've been doing, I'm going to have negative 6 minus 7, 30 minus 6, negative 8 plus 56, and 40 plus 48. And so whenever I put those together, I'm going to have negative 13, 24, 48, and 88. Now let's swap these and let's find our product of B times A. Now we're used to multiplication not mattering whenever, or the order doesn't matter when we do multiplication, but this one's going to be a little different. If we do B times A, we're going to get negative 6 plus 40, 2 plus 80, 21 plus 24, negative 7 plus 48. And when we combine all of those values, we have 34, 82, 45, and 41. So notice that we did not get the same thing. In other words, matrix AB is not congruent to matrix BA. Your commutative property does not work with matrices. So now that means that we need to look at some properties and what we can do as far as multiplying with our matrices. And for the first one here, if we're doing matrix multiplication, if I have the product of matrix AB times C, then the order I can do would be something like this. Again, keeping each particular matrix in its same spot. That is very important for us. Now, with scalar multiplication, that is just a number. So if I had K times AB, well, that's the same thing as K times A times B, or A times K times B. That's going to be okay because scalar multiplication is just a number. Now, looking at our left distributive property, then that's going to change things a bit. So the left distributive property, that says that if I have a matrix C, and that is times the sum of A and B, then I can distribute and have C times A plus C times B, as long as I'm keeping the matrix C to the left. And the same would be true for the right. So if I have the sum of A and B times C, then that's going to be matrix AC plus matrix BC. And again, keeping the C on the right side. Okay, so another way that we can use matrices would be to go through and set up a matrix multiplication to show us some total costs in more like a spreadsheet. So here's all of the supplies that these two teachers have purchased. And so we can make a matrix from that, saying 6, 8, 4, 2, and 5, 3. We can make a second matrix for the cost, and that cost would be 15, 4, and 250. And what we can do with this is go ahead and multiply this through, and if we do, we should get a sum of $118.50, and then the next one, it should be $135.50. And so from that, we see that that top number, that was Mr. Smith, that's how much money he spent on supplies, and the bottom is Miss Wills, that's how much she spent on hers. Now, another way to use this would be over number crunching this. And a good thing for us to realize here is that the question itself is saying that they're earning a 15% profit on each item that they sell. And we're going to set up our matrix multiplication. And so notice it tells us to give our answer as a matrix. So we have to be careful with this. Now, when we set up again, just like earlier, all of these numbers here, that's going to make up the first matrix that we have. And so we're going to have 60, 84, 45, 75, 58, 28. We're going to have 40, 63, and 18, and then finally 91, 47, and 32. So from that, we need to set up with the matrix to show our 15% profit. So we need to take our price and multiply it by 0.15. And so that's going to give me 1.5, 1.8, and then 2.25, or 2.40, sorry. And when we do that multiplication, then we're going to get our total profit for each class. So the first one is going to be 349.20. The next one, 284.10, 216.60, and then 297.90. And so there's our list, and keeping in mind that the order that we had this is our freshmen, this is our sophomore, our juniors, and our seniors. So on number 20, which class earned the most profit? That would have to go to the freshmen. The total profit for the school would be the sum of all those elements. So that's going to be $1,147.80. And then how much more profit did the seniors earn than the juniors? You would subtract there, and that's going to give you $81.30.